simple of understanding subnetting, and what you are required to do, a sample of basic subnetting. Then in this next class that we shall have tomorrow on your side, I'm going to design several questions that will help us understand every concept in subnetting.
Okay.
Yeah. Okay, so the main aim of having the previous class about network addresses is just to understand the types of IP addresses, then the types of IPv4 address classes, for example, class A, B, C, D, and E, and we realized that we could only use from class A to class C, and also we understood the concept of private and public IP addresses. All right, so in this class, which is about subnetting, both classful and classless subnetting. We are going to cover what you mean by subnetting firstly. Just a minute. We are going to cover what you mean by subnetting. Then example question of classless or classful subnetting. Then in the coming class, which will be the tomorrow's class, we're going to cover the real world subnetting question based on what I implemented on my enterprise networking designs. I have 9 case studies. So I'm going to get the 9 case studies and we solve the subnetting problems on those questions. All right. So the first point, we have to understand what you mean by subnetting. Well, we normally have PLS. For example, in the task that we've been doing, I normally tell you that you use 192.168.1.0. So, for example, you've been given that IP address and you need to subnet. What is the meaning of subnetting? Subnetting is just a practice of dividing a full network into two or more smaller networks. For example, if you've just been given that 192.168.1.0 and you have 3 departments, and you've been told that each department should be in a different subnet. Now you do what is called subnetting on that block to achieve the objective. So we see that subnetting increases routing efficiency, it enhances security of the network, and also reduces the size of the broadcast domain. And other advantages you can see is a good security performance, easy management, and less broadcast domain as discussed above. So primarily we have 2 types of class subnetting. We have classful and classless subnetting, and we're going to understand this one in the coming classes. So for example, in this topology here, you can see, will this really explain it better? I'll just send this and open what will explain better. So this is one of the networks that I've been working on. So for example, you can see this is human resource, marketing, customer service, and IT department. You can see a network here as 192.10. I mean /26. Here is 192.168.1.64/26. So these network are in the same network block, although we've carried what is called subnetting. You can see they always start, they normally start from, they all start from 192.168.1 dot something, all of them. So what changes is just the host portion, which is here is 0, here is 64, here is 128. So what we did here is just called subnetting, but now this was called classless subnetting, and we're going to understand every concept in the coming classes. So that was just an example of how subnetting was done. And also in this simple topology here, you could see that you can see that on this router here, the network address that is used for this LAN is 135.70.2.0, and we can see the first host took that one and the second host took that one, and also that applies on this side. So these are the just concepts of networking, subnetting. But in this scenario, this is called classful. On the previous scenario that I showed you is classless. So you're going to understand what you mean by classful or classless subnetting. Classless and classful subnetting. So a method of splitting a classful or a classless network number into two or more smaller subnets. So then the subnets will all have the same size, determined by the maximum number of hosts per subnet. A subnet mask is used to configure subnets. So in the classful or classless IP address subnetting, we use IP address and subnet mask to do subnetting. So it's the IP address and the subnet mask that is helping us do subnetting. The only two. Then we see that each subnet has its own block size for subnetting as shown below. So for example, when you see any subnet mask ending with 128, then the block size is 128. Block size is just primarily what helps us move from one subnet to another. The step that you move from one subnet to another. If you want to move from this subnet to another, how many steps do you pass through? It's called block size. When any subnet mask ends with 192, then the block size is this one. When any subnet mask ends with 224, the block size is that one, and so on and so forth. It's very important, the concept of block size. You're going to understand them better when you started calculating subnets. And on the right side here, we have subnet mask and a slash notation. You could see I was giving something like used to 192.168.1.0/24. Slash 24 basically means when you come here and check where slash 24 is, yes, the slash 24. And if you correlate it to the a decimal number subnet mask, you will see that it's 255.255.255.0. So any subnet mask that is indicated with slash 32, you correlate it on this side. It corresponds to that other side. So 31 on the other side, 30 on the other side, starting from below here. 1 this side, 2 this side, that way. So in terms of subnet mask basically helps us to know which part of IP address is network portion and the host portion. So subnet masks, we can express them in terms of decimal numbers. This one, 255.255.255. something, subnet mask, or a slash notation. We're going to understand how the slash notation comes in. Alright. Example of a classful subnetting. So, for example, you've been given this network and this subnet mask, and you're being told to find a network ID, first and valid and the last valid host ID, and the broadcast ID. First of all, I'll explain. The network ID, as we learned earlier, is that portion of that IP address that tells us which network the IP address belongs to. But the host ID is the portion of IP address that tells us the parts of how can I say the parts that the host devices can take, the number of host addresses in that IP addresses. A broadcast ID is that the last IP address in that subnet. Broadcast, the last IP address to move to the next subnet. So before you move to the next step subnet, that last step, the last step to move to the next subnet is called broadcast ID. So for example, let's do simple calculation. We see that this is the network ID, the network address that have been given, and this is the subnet mask. So we use IP address and the subnet mask to do subnetting. That's the roadmap, and is the subnet mask is the roadmap that helps us to do subnetting. So let's start analyzing this case study. Considering this is a class C address, hence subnetting occurs on the fourth octet. You could remember in class C address there was something like n dot n dot n dot h, and we realized that the first three n's represented the network portion while the last h represented the host portion. So considering that this is a class C address, subnetting occurs on the fourth octet where there's host portion. Subnetting only occurs on the host portion, or not necessarily. It depends on the question. Yeah. So and the fourth octet value is 0. This fourth octet value is 0 on this point. So therefore, on looking at the subnet mask and block size table, I told this is a very, very important table during subnetting. When you're looking on this table, we see that the last value here, the last value falls within 128 because this is like from 0 to 128. So this 0 falls within 128, and then now the block size will be 128. So we say that the block size is that kind of a step that is telling us how to move from one subnet to another. So we use this step. So the block size for subnet mask 128 is this one. Therefore, we will have two subnets from 0 to 127, then from 128 to 225. How did I say that? Why did I say that blocks helps us to move from one subnet to another? You can see the first subnet here is 0. The first network ID here is 0. But the network ID on the second subnet is 128. Here, the block size. It has helped us out to move from one subnet to another. So on the first subnet, here we have two subnets. On the first subnet, the first valid host ID is this one. This is just a network ID. Now for the first valid, now the first one is now 1. And the last valid is 126. And the the broadcast ID is 127. We say that broadcast ID is the last step to move to the next subnet. If the next subnet is 128, now the previous step is 127. And now if the broadcast ID is 127, now the last valid host ID should be 126. Subnetting is sometimes hard to understand, but when you handle a lot of problems, you get to understand it better. That's how I learned subnetting. Yeah. So for that, the same case applies here. The first valid host ID is 129 because this is the network. So the first one should be +1, 1. And the last valid, we say that from 128 to 255. So 255 is the last one. The broadcast ID, I mean. Now the last valid ID is 254. Now let's move to the next case so that you understand better. The next case we have a classless subnetting, which is very very important because a lot of cases that we're going to handle, mostly in the next class, I'm going to prepare a document with or close to 9 case studies, case scenario, and we're going to subnet and come up with the right IP addresses based on the case studies. So given sorry. um Given this network with the subnet mask of this one, find network ID, first and valid host ID, and broadcast ID. So we see the roadmap of subnetting. We use IP and a subnet. And the most important part here is the thing that gives us the guidance is the subnet mask. We check on the subnet mask. How do I say this is a classless IP address subnetting? I mean, you check on the subnet mask because let me move up. This is classful. You could see that this is a class C address, and for class C address, this is the normal subnet mask. So it becomes a classful. This was a class C address, and for class C address, this is the normal subnet mask. When you come here, this is also a class C address, but the subnet mask is not the normal subnet mask of a class C address. Class C address subnet mask should end with 0, but now here it's ending with 192, making it classless. Now it doesn't have any class because it has unrecognized subnet mask. Now we classify it under classless IP address, classless subnetting. All right. So we say that what gives us a guide to do subnetting is the subnet mask. We check the last value of the subnet mask, and we come to this table. The last value is 192. If you come to 192 and check under subnet mask, you should see that here is 192, and 192 corresponds to 164 block size. So therefore, looking at the subnet mask and block size, the block size of mask of 192 is 64. So it's the 64 that we use to move from one subnet to another. So for example, we can have a subnet from 0 to 63, 64 to 127, 128 to that one. So what we are going to do here, I cannot open Notepad. So for the first subnet, the network ID will just be this one, .0. Now in the second subnet, we add 64 because we say that block size is just a step to move to the next subnet. We add 64. Then we see that subnet mask ends with 192. So when we compare 192 on the block size subnet mask table, we see that 192 corresponds to 64 block size. So when the first octet network ID should take the first, just this, the normal here. That should be the network ID of the first subnet. Now for the second subnet, we should add 64. So the network ID of the second subnet should be 64 here, .64. On the third subnet, we add 64 still, and it becomes 68. On the fourth subnet, we add 64 still, until it reaches 254. But now here, 255. But now here, if you add 64, for fifth subnet, it will be much higher than 255. So it ends here. only 4 subnets. So that's where we calculate first valid host ID, last valid host ID, and broadcast ID. So if the network ID here is 64, then the broadcast ID on the first subnet should be 63 because it's the last step to the next subnet. If the broadcast ID under first subnet is 63, then the last valid host ID under first subnet should be 64. It's quite much easier to understand, but a bit confusing, you know. So if you start the case scenarios, I believe you understand them better. Then finally, there's also alternate ways of alternate method of subnetting, but through the using of binary numbers. So for example, this is a network and this is a subnet mask. What you do, we just convert this subnet mask into binary. If you convert this subnet mask into binary, we get this value here. Now, network bits are represented by ones, host bits are represented by 0. So considering the binary values above, the borrowed network bits are 2. So for a normal class C address, all of this should be 0. But because we have 1 1 here, meaning the 2 1 1 are borrowed. So we just have to calculate the number of subnets. How do we calculate the number of subnets? We just say 2 raised to power n, which is this one. 2 raised to power n, and you get the number of subnets. N represent the number of network bits, 1, 2. On the borrowed side, 1, 2. So 2 raised to power 2 is 4. So, and the number of hosts, we have realized that we have 4 subnets. What about the number of hosts per subnet? We just say 2 raised to power n minus 2. So the number of host bits are 6. Then you get this value. Alright, so if you compare this value to what we calculated here, you see that they are the same, because we've been told the number of subnets are 4 and the number of hosts per subnet should be 64. If you come here, you can see that we have how many subnets? 4. 1, 2, 3, 4. And how many number of hosts per subnet? 62. Okay. Alright, so that's all about this simple subnetting. And in the next class, I'm going to design case scenarios. Around 10 of them of the networking project that I've done. Then we analyze them, do subnetting, and you understand better how subnetting works in a real world networking scenario. So thank you so much, and let's meet again in the next class.